Oh, hi. So what brings you in today? That's right, I did say that we would talk a little bit more about blood. We'll learn about blood types today. A, B, O, as well as Rh, the positive and negative. Let me just clean up here and we'll get to it. So the main idea with blood type is that on the surface of people's red blood cells, we have a number of proteins on them. And those proteins put into another person have the potential to cause that person's immune system to make antibodies or generate antibodies. And because of that, those proteins that can generate antibodies in another person are called antigens. Most blood type issues or transfusion issues or reactions are due to two main blood type antigens. It's either the ABO antigen group that you have, where there are three types. You might have A antigens, or B antigens, or O antigens, or any combination. The other antigen that causes issues with blood transfusions is called the Rhd antigen. Now there are many other antigens, but these are the ones that cause the strongest reaction in a person's immune system when they get that type of blood. The main issue here is that a person will make antibodies against any type of blood antigens that they don't have in their body. And so if someone is O, meaning that they have no A or B antigens, they would make antibodies that would attack A and B antigens. Now, when we talk about these antigens, we talk about them as proteins, but really they're something similar called a glycoprotein, a protein with sugar molecules that are attached to it. And so this is the difference between the O, A, and B antigens. You would have the protein portion here and the red blood cell here. So this is not to scale, of course. The red blood cell much larger, the protein portion large, and the sugar molecules are relatively small. With someone who has O-type blood, this is called they have an H protein, is what it's referred to. And it has some sugar molecules, and it has a fucose, which I've color-coded red. There are enzymes that a person might have that would either attach another sugar called galactose or a different type of sugar called GalNAc. And that would determine if this person's H protein is A or B. There's a very rare blood type called Bombay, which even lacks the fucose. And so people who have this antigen would make antibodies against this type if they don't have A. And similarly, someone who has type A blood would make antibodies that would target B as long as they also didn't have B. You could have both. Someone who has Bombay blood, however, because they're missing the fucose, would make antibodies against all three of these, and they could only receive that same rare blood type. They could not even receive O. So here's that concept represented visually, that if someone is type B blood, it means on their red blood cells they have B antigen, but anti-A antibodies floating around in their blood plasma. Type O, even though there is an O antigen, typically just represented as not having them. In their blood, they would have anti-A and anti-B antibodies that would attack the B antigen or the A antigen if somehow that blood were put into this person. The process of a blood type being rejected is called agglutination. It's where an incompatible red blood cell that was put into somebody, they would clump together. And so here are some examples. If you had a donor who was A positive, it means that on their red blood cells, they have A, and the positive means that they are positive for Rh. They have Rh antigens as well. And if you were to try to give this person's blood to someone who is AB positive, when you donate blood, you only are donating the red blood cell portion, they pack those red blood cells and they separate it from the plasma. And so you're not giving them the antibodies, you're only giving them the red blood cell. And so that is removed and put into this recipient. And so this recipient, being AB positive, they would not have antibodies against A. They would not have antibodies against B, and they would not have antibodies against Rh because they have all of those antigens on their red blood cells. And so there's nothing to cause harm or agglutinate this donor red blood cell. Here we have a bad reaction where the donor again is A positive, where they have A and Rh antigens as well as anti-B antibodies. But again, we're only going to take out the red blood cell and we're going to give it to someone who is B positive. And so they have B and Rh antigens on their red blood cells. That means that they would make antibodies against A because they don't have A antigens. And so when we take this red blood cell that has A and Rh antigens, the antibodies present in this person's plasma would attach to them and cause them to clump up with other of those same red blood cells. That is a process called agglutination. Now there's a difference between A and B sensitivity compared to Rh sensitivity. Getting the incorrect ABO type, you would have a reaction the very first time. From birth, you are making antibodies for A or B if you do not have those antigens. Slightly different for the Rh protein. You need to be exposed to that one time to prime your immune system to make large amounts of those antibodies. And so it's really only the second time that you're exposed to Rh proteins, if you're Rh negative, only the second time that you would show a reaction. This comes up with something called hemolytic disease of the newborn. This is when a woman who is Rh negative, meaning she does not have Rh proteins on her red blood cells, becomes pregnant from a male who is Rh positive, meaning that he does have Rh antigens on his red blood cells. The fetus may inherit the gene for Rh protein from the father, and so the fetus may be Rh positive. And that mother, because she is Rh negative, could be producing Rh antibodies. The Rh antibodies are monomers, they're called IgG antibodies, and they can cross into the fetus's blood. And so if those Rh antibodies go into the fetus's blood and the fetus's blood is Rh positive, those antibodies could attack the fetus's blood. This does not happen with AB type because the antibodies that fight A and B antigens actually form a pentamer, or a very large structure that cannot get into the fetus's blood. Only the Rh antibodies can get into the fetus's blood. So I hope that was all clear enough about blood type. We're going to be using models in class to model the different blood types, the 8 common blood types, in order for you to try to figure out who could donate to whom could receive from whom, and why. Now, one thing that I didn't mention earlier, but you may have thought about, you may have heard of plasma donation. So in addition to red blood cells to carry oxygen, sometimes people get plasma donations, and that would be for things like donating plasma for the antibodies themselves. We've heard about that in the news in terms of COVID, where someone who has had COVID might have antibodies for COVID, and so you can give somebody else that plasma. The rules for donating plasma are just the opposite of the rules for donating red blood cells, because you're not putting the antigens in, you're putting the antibodies in. And so the antibodies that come with the plasma, you need to make sure that they don't have antibodies that will target that recipient's blood. Another reason that people might get a plasma donation is for something that's in our next video, which are clotting proteins. If someone's got a disorder where their clotting proteins don't work, you can give them someone else's plasma, because in addition to antibodies, it also has the blood clotting proteins, which will help that person's blood stop any breaks in blood vessels. So again, thanks for watching, and I hope that you've enjoyed this and learned something.